take a look at our first of our two quiz questions. And again, I hope you understand that if I'm taking the time to review something, it's important. Okay? I'm not putting stuff down on pieces of paper saying to myself, how can I waste their time? My thought process is there's only so much time between now and the final exam. How can I help them maximize their time? How can I help them get the most out of what it is they're going to do so that you get the best grade possible? That's exactly what went into the design of these particular review sheets. And I think they'll help a lot if you work them and allow for it. So the first question was, question?
How do you get 5 for the slope?
All right, I'll go right through the whole thing now. This is one that completely stunned me, exactly what Ashley just asked. I thought this was unbelievably easy, and obviously I'm wrong. Because in the class, maybe 5 or 6 of you got it right. Look, to find the slope, another name for slope is rate of change. So I look at the table, what are the y's going up by? 5. What are the x's going up by? 1. And slope or rate of change is the change in y over the change in x. It's 5 over 1.
I put 1 over 5.
Yeah, a couple of people did that, but you know what a lot of people put? 1.
1.
How did you get 1?
0.
Probably it's the 1 over 5 and you just get 1. It feels like
The
half of
0.
5 or something.
Davis?
I don't know.
Anyway, so, excuse me. The slope of the line works out to be 5. Really 5 over 1, but 5 is there. Next, the y-intercept pairs up with the x-axis with 0 always. Y-intercept always pairs up with 0, so that's -2. And then using y equals mx plus b, I get y equals 5x minus 2. And so you know this was worth 15, this was worth 15, and this was worth 20. Okay? Any questions on that? All right. So now we go to the last one, number 2, and nobody, I don't think anybody got this completely wrong. A lot of people got it completely right, and a lot more people got it partially right. Let's be careful here. Ready? I have to distribute the 2. 2n plus 10 plus 3n minus 1. I don't do anything to that. Is n minus 3. Same side? So that's 5 n's, and then positive 10 and negative 1 make 9. Now, when I subtract the n, I get 4n, and here's where some people made a mistake. Minus 9, minus 9. What are 3 negatives and 9 negatives? Negative 12. Then I divide by 4, and I get n is negative 3. So one thing I would recommend to you to do with a question like this is, Melvin, just take the time when you're done with it to take a negative 3 and plug it in the original equation and check it. And make sure you get the same thing on both sides. I mean, you have a calculator to do the operations with you. It's not very difficult. And then you can be sure that you got the answer right. Otherwise, you might have to go back and check it over again. See where you might have made a mistake, okay? Any questions?
No.
All right, so you know you got 2 more quizzes coming exactly like this. One of them will be tomorrow. I might even make 2 of them tomorrow. I'm not sure, okay? Not sure how that's going to play itself out. All right, next up. Again, if it's on here in some way, shape, or form, definitely not exactly the same, but in some way, shape, or form, you are going to see questions like this on your final exam. Or you'll see tons of it next year. Lenny, head up, bud. So let's take a look and see how you did and see if you want to ask any questions. Okay? Again, every time you see something you don't know how to do and you pass it on by, that's points off your final exam. Think of it that way. Okay? And I didn't bother drawing the points on here because of the way it laid itself out, but I have 7, negative 2. Remember, if you flip over the y-axis, the y stays the same. The other one gets negated. And the next one is 1 comma 12. Okay? Next sheet, there's all the answers. When on letters E and F, the only thing that matters is the last answer. I was just showing you some scrap work along the way so that you would see if you were doing it right.
What's oops?
Oops means I screwed up and forgot to give you a point to put in there.
I know, I was looking at it, I'm just like,
Right.
why does that look weird?
Yeah, When I was young, about your age, I always got in arguments and I always had to be right. And now I don't care. But when I was younger, one of the victims of my constant need to be right and show how intellectually superior I was my sister Sandy. And I actually saw her at church the other day, and I looked at her and I go, you know, I'm so glad that a few years ago I figured out how liberating it was to not have to be right all the time, to just do your best and accept the fact that sometimes you're going to screw up. And I do try hard. I really think I do the best I can, but I do screw up. And I told my sister, I said, in my class we have the Lindquist Daily Dumb Mistake. So I said, every day, I said, my students know to expect me to screw up. They do not expect me to be perfect. Nor do I of you. It's your direction, not your perfection, as my pastor at church would say. All right, check these out. Any questions, ask. Be happy to go over them. Right, your homeworks should all be on your desks. You should be looking at your homework, comparing it to what's up here, seeing if you got it right or wrong. If you do your homework and you don't see if you're getting it right or wrong, and most importantly, if you get it wrong, realize what the correct thing to do is, then you will be stuck in that perpetual level of achievement. You will not get better. Ooh. Ava, can we get rid of that, please? That's not when you're darn good and ready. That means right away. Otherwise, I can take it and throw it out. Okay, scan 3. We good? Okay. Remember, if you have questions, ask. For this bottom piece here, you always have to make it say y equals. And then you can look for mx plus b. The slope is always the number in front of the x. It does not include the x. Okay? Tried to draw it here. If you flip it over the x-axis and slide it 7 units to the right, it lands directly on top. Shrink the size down here a little bit. Right, this is the line of best fit because it kind of goes through the middle of all the points. That's what we're looking for, roughly the same number of points on each side. This is terrible. This one is a little bit off. That's awful too. All right. So the line has to go through the points, through all of them, not through just the center like that. Now, we get into the kind of questions that, in my experience, are the weakest part of our scientific notation game. Generally speaking, I feel like we're pretty good at scientific notation. But the adding and subtracting, the very first years that I taught it, I still use the lesson plans from the first years that they did Common Core Math 8. Melvin, pick your head up. But I've changed them every year a little bit. I go back and I modify them and I tweak them. So the first year, they put a number of questions on about adding and subtracting scientific notation. And I went back and put some on, and then the year after that, they had some, so I put some on. So I still think I do more with multiplying and dividing than I do with adding and subtracting, so I'm kind of careful to make sure I go over this a lot by the final exam. If you're going to add or subtract, and it says how much more, which means I'm going to end up, not how many times more, but how much more, that's a subtraction problem. And I have to write them as standard numerals, do my subtraction, and then convert back to scientific notation. That is the most dependable way to do it. For people who are outstanding at scientific notation in their head, it's possible to do it with the exponents, but very few people can do that, so I strongly recommend doing it this way. Okay? Another one. Again, you see I convert to a standard numeral, I do the addition, count 6 places, so the exponent is 6. In this one, you'll notice there's a dilation. A dilation does what to a figure every time? Bigger or smaller, right? If it's 0.5, it makes it smaller. If it's bigger than 1, it makes it bigger. So that means everything is shrunk proportionally, and that's what similar figures are. So they come out to be similar, but they're not congruent. As soon as there's a dilation in there, they're not going to be congruent. Okay, here's the goldfish problem you've probably seen 5 times this year, maybe 10.
The same goldfish you just take.
Okay.
I drowned.
And here's the last
I
one.
escaped. I went through the left.
Somewhere on your test, you're going to have to say a point of intersection. In this case, danger, danger, danger. They skip one line in each one here. So it's 4, 10, not 8, 10. Any questions? All right, so now you have in front of you the correct answers to all of those questions. I hope you're going home and studying it, Diego. That you're getting yourself a little bit better every day. We're going to certainly find out when we take the test on Friday how you guys are doing.
Happy birthday, Ashley. What?